Welcome to Blueprint to Reality. In today's episode, we're tackling a critical topic for cities prone to earthquakes: seismic retrofitting. As the risk of earthquakes continues to challenge engineers, retrofitting is the solution for making older buildings and structures more resilient to seismic activity. But how exactly do engineers strengthen existing structures, and why is it so important? Let's break it down. Why is seismic retrofitting needed? First, let's talk about why seismic retrofitting is crucial. Many buildings were constructed before modern seismic design codes were in place. These structures, whether they're schools, hospitals, or bridges, are vulnerable to collapse during an earthquake. Without retrofitting, these buildings pose a huge risk to human life and infrastructure. Seismic retrofitting helps bring older structures up to today's standards, ensuring they can better withstand the powerful forces generated by earthquakes. Identifying weak points. The first step in retrofitting is to identify weak points. Engineers conduct detailed assessments, looking for structural vulnerabilities like soft stories, inadequate connections, or materials that don't respond well to seismic forces. For example, older concrete buildings often have weak connections between floors and walls, making them susceptible to shear forces. By identifying these vulnerabilities, engineers can develop targeted strategies to reinforce the structure. Common retrofitting techniques. Once weak points are identified, engineers employ a variety of retrofitting techniques to strengthen the building. Let's look at a few common methods. Base isolation. This involves placing flexible bearings or pads between a building and its foundation, allowing it to move independently of ground motion. It's like giving the building shock absorbers to cushion the impact of an earthquake. Shear walls. These are walls added to resist lateral forces. By increasing a building's lateral stiffness, shear walls help reduce the swaying motion that can cause collapse. Bracing systems. Engineers may also install steel or reinforced concrete braces to add rigidity to a structure, preventing excessive movement during seismic activity. Column and beam jacketing. Wrapping or jacketing columns and beams with materials like steel or carbon fiber strengthens them, increasing their load-bearing capacity and preventing failure under seismic forces. Impact of retrofitting. Seismic retrofitting isn't just about strengthening a structure, it's about saving lives and protecting essential infrastructure. Take the example of schools, hospitals, and emergency services buildings. Retrofitting these structures ensures they remain operational after an earthquake, providing critical services when they're needed most. Retrofitting also reduces repair costs in the aftermath of a quake, making it a long-term investment in safety and sustainability. Seismic retrofitting is one of the most effective ways engineers can protect communities from the devastating impact of earthquakes. By reinforcing existing structures, we not only preserve our infrastructure, but also safeguard the lives of those inside. That's the power of engineering in action. Thanks for watching Blueprint to Reality. Be sure to like, subscribe, and hit the notification bell for more insights into the world of civil engineering and structural design. Stay safe, and we'll see you in the next video.